Hello everyone, this is Dr. M. Pavan Kumar Reddy, Assistant Professor, Department of Mathematics, VIGNANA JYOTHI, Institute of Engineering and Technology. Today we'll learn quadratic forms and nature of quadratic form. See, content, quadratic form, definition, matrix of quadratic form, canonical form or normal form of a quadratic form, rank, index, signature of a quadratic form, nature of a quadratic form. So first, what is meant by quadratic form? So quadratic form means it's a homogeneous, quadratic means it's a degree 2. So homogeneous expression of the second degree in any number of variables. The variables can be 2, 3, 4 or any number of variables. The degree of the expression must be 2. That is, every term must have same degree, that is 2. A homogeneous expression of the second degree in any number of variables is called a quadratic form. A simple example is, see, it is example 1. 9x square plus 5xy minus 4y square. Observe here, first term 9x square. X square, it's a degree of this term is 2. And second term, x and y, the variables are occurring product, x power 1, y power 1. So 1 plus 1 is the second degree term again. And the last y square is also second degree. So every term of same degree, that is 2, is a quadratic form in 2 variables. Since it involves only 2 variables x and y. So it's a quadratic form in 2 variables. In the similar manner, we have an example for 3 variables. See, 3x square plus 3y square minus 4z square plus 2xy minus 3yz plus 4zx is a quadratic form in 3 variables. See here. Here 3 variables are involved, x, y and z. See, every term have same degree. See, degree 2, degree 2, degree 2. So here is a product terms x, y, yz and zx. So this is a quadratic definition of quadratic form. So this is a particular case in 2 variables and in 3 variables. Now we'll generalize it to n variables. See, this is quadratic form. The definition can be generalized to n number of variables. An expression of the form, see, generally a quadratic form is denoted by Q, capital letter. X transpose A X. So X is the vector, variable vector. What are the variables involved in that vector? Say n variables. So x1, x2, x3, so on, xn. Okay, X transpose. Generally, X is a vector, means we consider here is a column vector. Transpose means it's a row vector. A is the matrix with all real numbers. X is a vector, x1, x2, x3, so on, xn, column vector. See, this can be expressed as, see, this is summation I is equals to 1 to n, j is equals to 1 to n, aij, xi, xj. aij, xi, xj. This is called quadratic form in n variables. See here, where this aij is there, aijs are all constants, real constants. We'll study only here real quadratic form only. So therefore, aijs are all constants. Okay, and is called a quadratic form in n variables. The variables involved are x1, x2, x3, so on, xn. Okay, so that's why is the variables of constants involved are called real. All are real numbers. That's why it's called a real quadratic form. It's called a real quadratic form. So let's expand this one. Okay, see here, that is, we write it is x transpose Ax is equals to, this is, expand it first, keep I fixed and j varies from 1 to n, that is a1, I equals to 1. Okay, j varies from 1 to n. Let's see here, put here a11, I fixed 1, j 1, a11, I1, j1, x1 square, x1 into x1, x1 square. Next, I fixed, so that's why it is 1, j varies 2, j equals to 2, a12, x1, x2, plus so on, a1n, x1, xn. Similarly, for I equals to 2, a21, x2, x1, a22, x2 square, so on. So, like that, for n equals, for n, I equals to n, an1, x1, xn1, xn, x1, sorry, and plus an2, xn x2 plus so on ann xn square. See here, the variables are x1, x2, x3, so on xn have square terms, product terms. Okay. Now let's simplify this one. A11 x1 square. We have x1 x2 term here as well as x2 x1 term. x1 x2 x1 into x2 is same as x2 into x1. So combine these two terms. So the coefficients a12 plus a21 into x1 x2 plus so on in the similar manner. If you proceed, we get the same for a1n an1. See here, a1n x1 xn, and here we have an1 xn x1, both are same. So take common a1n plus an1 x1 xn. See, these are all product terms. Next, in the similar manner, square terms. This is a22 x2 square, and similarly a23 a32 x2 x3 and so on. This is ann xn square. This is, let's see, this quadratic form can be represented in the matrix form as, see, q is equals to this expression we know. See here, x1 x2 x3 so on xn, it's a row vector, that is x transpose. Okay, and a11 a12 so on a1n, a21 a22 so on a2n, and an1 an2 so on ann. It's a matrix of order n. So square matrix, no need to say n by n. Okay, it's a square matrix of order n. And x1 x2 x3 so on xn, this is a column vector. Now we can write this one as we know. This is x is a column vector, this is the matrix A, and this is a transpose of the column vector x. So it is x transpose. So we can write a quadratic form as x transpose ax. What is x is? It's a variable column vector with variables x1 x2 x3 so on xn. And here what is A is, A, this is known as matrix of quadratic form. A is known as matrix of quadratic form. Okay. Now let's see, suppose if a matrix is given, how to write the quadratic form? If a quadratic form is given, how to write the matrix? Okay, we'll see. So first, let's see an example. Given that A is a matrix of order 3 with elements A, H, G, H, B, F, G, F, C. And remember always, here the quadratic form, the matrix of quadratic form is always a symmetric matrix. Always a symmetric matrix. So A is given and X is the vector, is a variable vector with variables given X, Y, Z. Its transpose becomes row vector X, Y, Z. Then the quadratic form. So how we write the quadratic form? As we know that the quadratic form is Q is equals to, it is X transpose A into X. That is equals to, what is X transpose? It is row vector X, Y and Z. And the matrix A is A, H, Z, H, B, F, G, F, C is the matrix, and X, which is a column vector with variables X, Y and Z. Now simple matrix multiplication. See, this is a matrix of order 1 by 3, 1 row, 3 columns, and it is a matrix of order 3, this is 3 by 3, and is a matrix of order 3 by 1. Observe here, first we'll multiply these two. Multiply these two. See, number of columns in the first matrix is equals to number of rows in the second. So the matrix multiplication is compatible. The resulting matrix is of order 1 by 3. 1 by 3. Okay. Let's multiply this. It is first row with all columns. First column first. It is AX. See here. It is AX. Okay. Plus HY. Plus GZ. This is first row, first column is the first row, first column element. Okay. So 1 by 3 matrix we get. So first row with second column, it is HX plus BY plus FZ. Similarly, third, it is GX plus FY plus CZ. Okay. And now the vector, it is X, Y and Z. Observe here, this is a matrix of order 1 by 3 and is a matrix of order 3 by 1. Let's see. Now, multiplying these two, the number of columns in the first matrix is 3, number of rows in the second matrix is 3, so matrix multiplication is compatible. The resulting matrix is of order 1 by 1. Only one element we get. So that is first row with first column. Only one element. So AX plus HY plus GZ into X. So therefore it becomes AX into X. It is AX square plus HY into X. It is HXY plus GZ into X. It is GXZ. Okay. Next. Plus HX plus BY plus FZ into Y. So it is HXY plus by into y square plus fzy plus gx plus fy plus cz into z. So it is gxz plus fyz plus cz square. Let's simplify this one. So write all square terms together. So ax square plus by square plus cz square plus product terms together. See here, hxy plus hxy. So it is 2hxy. Okay. gxz plus gxz. gx plus gxz is 2gxz or zx also you can write. And fzy plus fyz, both are same. So 2fyz. 2fyz. So this is the quadratic form. So if matrix is given, we can write the quadratic form by writing x transpose A into x. X is the variable vector, A is the matrix of the quadratic form. Okay, like this we write the quadratic form if matrix is given. Okay, let's see, suppose if quadratic form is given, how to write a matrix. Okay, let's see. So matrix of quadratic form, that is quadratic form is given. So we know that a quadratic form Q can be expressed in the form x transpose AX. Okay, here A is called, the symmetric matrix A is called matrix of quadratic form. Matrix of quadratic form. Let us consider this is an example. Okay, consider this one. Say x square plus 2y square plus 7z square plus 2xy plus 6xz plus 10yz. Okay, now how to write the matrix if quadratic form is given? So first, see, remember square terms, the coefficients we have to write. Okay, square term coefficients are diagonal elements. First, what is the order of quadratic matrix? Okay, so here how many number of variables are involved in the quadratic form given? Observe here x, y and z. So 3 variables involved. So we are going to get a third order matrix. We are going to get a third order real symmetric matrix. How to write that is, see, the coefficients of square terms are, see, x square, x into x, nothing but the first variable into first variable, nothing but first one position element, its coefficient. So x square coefficient here. So the square term coefficients are along the principal diagonal we write. X square coefficient 1 position, y square coefficient 2 position, z square coefficient 3 position. Okay. Next, coming to the product terms. So xy coefficient, yz coefficient and xz coefficient. Xy means it's the first variable into second variable. So therefore it is 1 position. Its coefficient is 2. Observe here, it is a symmetric matrix. So the coefficient of xy must be shared to the positions 1, 2 as well as 2, 1. So the coefficient is 2. It has to be shared to 1, 2 position as well as 2, 1 position. That's why, so dividing it with 2. The coefficient of xy dividing with 2. That is 2 divided by 2. So here we write 1 and here we write 1. And here the coefficients are 1, 2 and 7. Similarly, let's coming to the coefficient of xz. Xz means is the first variable and the third variable. So it is 1, 3 as well as 3, 1 position element. Its coefficient, it is 6. Let's divide it into 2 parts. 3. So here we write 3 and here we write 3. Similarly, yz coefficient. Yz means second variable and third variable. Its coefficient is 2, 3 position and 3, 2 position element. So dividing it with 2. So here we get 5 and here we get 5. So like that we write the matrix of quadratic form. So this is, if quadratic form is given, we can write the matrix, real symmetric matrix. This is the procedure to write a matrix of quadratic form. Okay. So now let's see one more example. How number of variables are involved here is, observe here, 3 variables, x1, x2 and x3. So always the variables need not be x, y, z. Sometimes it may be x1, x2, x3 or y1, y2, y3. Okay. So x1, x2, x3. So 3 variables involved. We are going to get a third order real symmetric matrix. Let us denote the matrix with A. Okay. Since it is third order. Okay. So I am writing, see, this is 3 by 3 matrix. First, so the variables are x1, x2, x3 and their coefficients, x1 square terms coefficient. See here, x1 square, x2 square, x3 square. Their coefficients are along the principal diagonal 1, 2 and 3. 1, 1, 2, 2 and 3, 3 position elements. Next, x1, x2. Okay, x1, x2 means first and second variable. First and second variable, its coefficient is 4. So let's divide it with 2. We get 2. So therefore, it is 1, 2 position. So we write 2 here as well as at 2, 1 position. 1, 2 position and 2, 1 position. We write the coefficient of x1, x2 dividing with 2. Next, x2, x3. It is second and third variable. So its coefficient is 5. Let's dividing it with 2. That is 5 by 2. So it has to be written at 2, 3 position as well as 3, 2 position. So 5 by 2. Next, x3, x1, that is third variable into first variable or first variable into third variable. Its coefficient is 6. So dividing it with 2. So we write at 1, 3 position as well as at 3, 1 position. So this is the matrix of quadratic form. Observe here, it is a symmetric. Symmetric means, what do you mean by symmetric actually? It is A transpose equals to A. If the transpose of the matrix is same as the given matrix, the matrix is said to be a symmetric matrix. So that is, first row is same as first column. 1, 2, 3, 1, 2, 3, 2, 2, 5 by 2, 2, 2, 5 by 2, 3, 5 by 2, 3, 3, 5 by 2, 3. So this is a real symmetric matrix. All the elements are real. So is the matrix of quadratic form. Okay. Let's move on to the next. See, canonical form or normal form of a quadratic form. Of course, canonical form or normal form is also a homogeneous expression of second degree. But what is the difference between canonical form and quadratic form? Simple, quadratic form can have square terms. See here, this is a quadratic form. Quadratic form have square terms as well as the product terms. But whereas canonical form have only square terms. Canonical form have only square terms. That's why is also called sum of square terms. Sum of squares form. Also called sum of squares form. Okay. See, observe here. Let x transpose Ax be a given quadratic form in n variables. So it's a quadratic form in n variables. Okay. Then there exists quadratic form in n variables means here we can have square terms as well as the product terms. Okay. Then there exists a real non-singular linear transformation. Linear transformation. This is x is equals to py. X is equals to py. See, this you studied in second unit, the transformation. Okay. Here y is the another set of variables, say y1, y2, y3. Suppose I'll explain this one with the 3 variables. Okay. Suppose x is a vector with variables x1, x2 and x3. Okay. And y is the another variable vector with y1, y2 and y3. A quadratic form in x1, x2, x3 variables is given. Y is the another set of variables, say y1, y2, y3. If you consider a transformation x is equals to p into y. P into y. What is actually here P is? P is a real non-singular matrix. What does it mean by non-singular? Non-singular means determinant of the matrix P is non-zero. Also, in other words, we can say the columns in the matrix P are linearly independent. Columns in the matrix P are linearly independent. So, here P is non-singular. And let us consider, since it is y is a variable vector of consisting 3 variables, so P must be third order. P is a matrix of order 3. Square matrix must be. It is 3 by 1. Okay. So 3 by 3 into 3 by 1. The resulting matrix is of order 3 by 1. Of course, the left hand side matrix is of order 3 by 1. So equating corresponding elements. So x1 is equals to, you get an expression in terms of y1, y2, y3. Okay, x2 is equals to, you get an expression in terms of y1, y2, y3. x3 is equals to, you get an expression in terms of y1, y2, y3. if you substitute this x1, x2 and x3 in this quadratic form, say, you are going to get an expression, new quadratic expression in terms of y1, y2, y3. y1, y2, y3. That you are going to get in this form, which doesn't contain product terms. Only it contains square terms. Only it contains square terms. This kind of form is called canonical form or normal form, or also called sum of squares form. Also called sum of squares form. So here the coefficients are lambda 1, lambda 2, lambda 3 and so on, lambda n. Of course, these coefficients of all are real numbers, but maybe 0, positive or negative. Okay, these lambda 1, lambda 2, so on, lambda n values may be 0, may be positive or negative. Okay, so the simple quadratic form is also a homogeneous expression of degree 2. Canonical form is also a homogeneous expression of degree 2. But the difference between quadratic form and canonical form is quadratic form contains square terms as well as product terms, whereas canonical form contains only square terms. That's why it's called canonical form. Normal form is also called sum of squares form. Okay, so this is so which transforms this transformation transforms x transpose x. If you put x is equals to py, what you are going to get here? X transpose ax. If you substitute instead of x py, that is py transpose a into it is py, then this is, as we know that AB transpose is B transpose into A transpose, A into P Y. This is equals to Y transpose into P transpose AP into Y. So here this Y transpose, what is this P transpose AP is? Remember, this P transpose AP is a diagonal matrix. This P transpose AP is a diagonal matrix. Okay. P transpose AP becomes a diagonal matrix. Only it contains diagonal elements. That's why it contains diagonal elements now. That's why you get only square terms. So only square terms. Lambda 1 y1 square, lambda 2 y2 square, say so on. It is generalized. Lambda n yn square. This is a canonical form or normal form, also called sum of squares form. Also called sum of squares form. Okay. So now we study what is rank, index and signature of a quadratic form. Okay. See, rank of quadratic form is nothing but very simple. It is x transpose x is the given quadratic form in n variables in general, let us say. And matrix A is there. We write a matrix A. The rank of the matrix A is also called the rank of the quadratic form. Rank of matrix A. Let us consider the rank of matrix A is say R. Say R. We know how to find the rank. We have determinant method or echelon form, normal form we studied earlier. Okay. So if R is the rank of the matrix A, R is also called the rank of this quadratic form. Simple. See, as we know that if rank is less than n is nothing but the matrix A. Since here A is a real symmetric matrix. Okay. Nothing but square matrix only. Determinant exists. If the determinant is 0, the matrix A is called singular matrix. Determinant is 0 means rank must be less than n. That is R is less than n. In such case, if rank is less than n, okay, in such case, n is number of variables. In such case, the quadratic form is called singular quadratic form. Okay, if the determinant is non-zero, is called non-singular quadratic form. Okay, if determinant is 0 or rank is less than n, the quadratic form matrix is singular, also called quadratic form is called singular quadratic form. If determinant is non-zero, then it is called non-singular quadratic form. Okay. Next, index of the quadratic form. Simple. Index means, suppose a quadratic form is given, we have to reduce it to canonical form. See, this is canonical form as we studied. Okay. So as we know that these lambda 1, lambda 2, so on, lambda n are maybe 0, positive or negative. So how many of them 0, how many of them positive or how many of them negative, that we don't know now. In particular case, we can able to know. Now, suppose that how many number of positive terms are there in the canonical form. See here, the number of positive terms in canonical form or normal form of the given quadratic form. Nothing but a quadratic form will be given. We have to reduce it to canonical form. After reducing it to canonical form, identify how many number of positive coefficients are there. in the expression. How many number of positive terms are there? That is called index of the quadratic form. That is called index. Generally, we denote the index by s, small s. We denote the index by small s. Similarly, signature now. Signature of quadratic form means, see, as we know, canonical form contains maybe positive, negative or zero terms, zero coefficient. Now, excess number of positive terms over the negative terms. Excess number of positive terms over the negative terms is called signature. Excess means, so actually how many number of terms are there in the canonical form? See, generally in number of variables in the quadratic form is n. See, in the canonical form also generally we have to get n, but sometimes the quadratic matrix of quadratic form may be singular. Singular means determinant 0. If determinant is 0, remember that as you already studied that eigenvalues and eigenvectors, if the determinant is 0, nothing but at least one of the eigenvalue must be 0. Okay. If in such case, you get at least one term as 0 term in the canonical form. In canonical form. That means the number of terms in the canonical form, instead of saying it is n, it is better to say r. It is better to say, since r is rank of the quadratic form. If r is equals to n, the matrix or quadratic form is called non-singular quadratic form. If r is less than n, the quadratic form is called singular quadratic form. Singular quadratic form. So therefore we can say that the number of terms in the canonical form is generally called as r. That r may be equals to n, r may be less than n. Okay. So the total number of terms are r in the canonical form. So now, how many number of positive terms are there? Yes. Then from total number of terms, if you remove positive terms, you get negative terms. That is r minus s number of negative terms are there. But what is actually signature? Excess number of positive terms. So excess means number of positive minus number of negative. Number of positive terms are s minus number of negative terms, which is nothing but s minus r plus s, which is simply we say 2s minus r. So this is the formula to determine the signature of quadratic form. Signature of quadratic form. Let's see the nature of quadratic form. See, this is nature of quadratic form. We can say the nature of quadratic form in two ways. I'll explain both. Let us consider that x transpose ax be a quadratic form in n variables. Let x transpose ax be a quadratic form in n variables. So we have 5 different kinds of nature: positive definite, negative definite, positive semi-definite, negative semi-definite, and indefinite. Let's see one by one. First one, positive definite. Positive definite. If r is equals to n and s is equals to n, what is the meaning of this? R means number of terms in the canonical form. Number of terms in the canonical form. If number of terms are equals to n, what is the meaning of that? Number of terms are equals to n means there is no zero term. There is no, all terms exist, either positive or negative. There is no zero coefficient. So this is r equals to n. Nothing but it is a non-singular quadratic form. So r equals. And s equals to n. What is the meaning of s? S is number of positive terms in the canonical form. Positive terms equals to nothing but all terms in the canonical form are positive. All terms in the canonical form are positive. In other words, we can also say in other words, that is A is the matrix of quadratic form. Just simple, find the eigenvalues of the matrix A. If all eigenvalues are positive, the quadratic form is said to be a positive definite. The nature of quadratic form is said to be a positive definite. Positive definite. Positive definite means all eigenvalues of A are positive, or all terms in the canonical form are positive, and the number of terms must be equals to the number of variables in the quadratic form. That is called positive definite. Similarly, negative definite. Negative definite means number of terms are equals to the number of variables, that is rank equals to n. Okay, or number of terms in the canonical form equals number of variables. But there exists no positive term. S equals to 0. That means index is 0. No positive terms exist in the canonical form. All terms are negative. In other words, one is all terms in the canonical form are negative. In other words, all the eigenvalues of A are negative. All the eigenvalues of A are negative. So in this case, the nature of quadratic form is said to be a negative definite. Is said to be a negative definite. Next, positive semi-definite. Positive semi. Semi means not full. So this is, say, R less than. What is the meaning of R less than n? That means the number of terms in the canonical form are not equals to the number of variables. That means the quadratic form is a singular quadratic form. Number of terms are less than. That means at least one coefficient among lambda 1, lambda 2, lambda 3, so on, lambda n are 0. Okay, that is rank is less than n. And number of terms are less than number of variables. And S is equals to R. So that means there are R terms exist. All terms are positive. But remember that all terms are positive. But all terms are not equals to n. Number of terms are not equals to n. There are lesser number of terms than n. So it is called semi-positive, semi-definite. In other words, we can say that all the eigenvalues of A are greater than or equal to 0, but at least one of the eigenvalue is 0. What is the meaning of at least one of the eigenvalue 0? That means determinant of A is 0. As we have one property in eigenvalues and eigenvectors, that is the product of the eigenvalues is equals to the determinant. If one of the eigenvalue is 0, nothing but determinant 0. Determinant is 0 is nothing but the singular quadratic form. Nothing but the number of terms in the canonical form exist are less than number of variables. So there exist R number of terms and all are positive. Okay, that is called positive semi-definite. Remember, at least one of the eigenvalue is 0 or at least one term is less than number of terms are less than n. Similarly, negative semi-definite. That means as usual it is R less than n. That is number of terms are less than number of variables. And there exists no positive term. All are negative terms only. In other words, we can say that according to eigenvalues, all the eigenvalues are less than or equal to 0. And also at least one of the eigenvalue is 0. In such case, the nature is said to be a negative semi-definite. So these are the cases. In all other cases, except these cases, in all other cases, we say that the nature of quadratic form is indefinite. The nature of quadratic form is indefinite. Okay, nothing but few positive, few negative. Okay, positive negative combination if exists, that kind of nature of quadratic form is said to be a indefinite. Okay. Next. So these are the few problems to work out. Okay. So I have given two problems. Write quadratic form. For these two matrices are given, write down the quadratic form, and two quadratic forms are given and write the corresponding matrix of quadratic form. So try to work out these problems. Okay, feel free to contact for any doubts. Pavan Kumar Reddy _m@vnrvjit.in. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.